ఒకసారి మీ స్టూడెంట్ మీ ఫ్రెండ్స్ చెప్పండి ఇమీడియట్ గా జాయిన్ అవ్వమని చెప్పి. అర్థవుతుందా? క్లాస్ సార్ వెయిట్ చేస్తున్నారు. మిగతా వాళ్ళందరూ ఒకసారి మీకు కాల్ చేసి అందరూ ఇమీడియట్ గా జాయిన్ అవ్వమని చెప్పండి. ల్యాబ్ స్టార్ట్ అవుతుంది 9 o'clock. స్పాక్స్ ఎవరైనా ఉంటే సిఐ స్పాక్ అండ్ నెక్స్ట్ సిఎస్ఎం స్పాక్స్ ఇమీడియట్ గా ఇంటిమేట్ చేయండి. అలవాన్స్ ఎవరైతే ఉన్నారో వాళ్ళందరూ ఇంటిమేట్ చేయండి. స్టూడెంట్స్ జాయిన్ అవ్వమని క్విక్ గా. స్పాక్స్ ఎవరైనా ఉన్నారండి? ఒకసారి రెస్పాండ్ అవ్వండి. హలో 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 అమ్మా, రెస్పాండ్ అవ్వండి అమ్మా. ఎవరైనా ఉన్నారా? స్పాక్స్ ఇస్ దేర్? హలో
Yes, sir. Hanuman, I think he contacted me. He said we'll start in 10 minutes. Hello, Ramakrishna garu. Hello. 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 Can one of the students can message me if I am audible or not?
Good evening, sir. Yes, sir, you are audible.
Okay.
Sir,
Thanks.
your voice is audible, sir.
Okay. Thanks.
Okay. Sir, Narendra sir, you started the session, sir. Meanwhile, the students will be joined, sir.
It's okay, and
Already 8:58, sir.
I'll start by 9:05. It's okay, and let them.
Okay, sir. Okay.
Yeah, I'll
Only
start
this
by
lab
9.
is having only 2 branches, sir. CSM and CA branches, sir.
Okay.
Okay, sir. Okay.
Okay,
Thank you.
then I'll start exactly at 9:05.
Okay, sir. Okay. Thank you.
Okay, thanks. Hello everyone. Let's start the session for today. It will exactly take 1 hour. It is 9:05 now, around. Till 10 we'll take the session. Maybe a little more, 10:05 maybe. So last time, like on Saturday, we covered 1 to 10. Today we will cover 11th and 12th. So comparatively, this 1 to 10 is different. So that is like we'll learn some concept and there is no data set, nothing. But in 11 and 12, we have a data set now. First one is about sentiment analysis. The second one, that is case study 1, is about sentiment analysis. So in this, we'll have some data set that contains products of like the reviews of the products that users bought like in online or something. So basically some electronic products are there. So for those, we'll see like whether the review is good or bad or something. So that's what we call sentiment of the tweets. And then we have a detect hate speech in tweets. So here, like in YouTube comments and everything, we will see like some people will post negative comments, right? So that kind of a negative comments are called hate speech tweets. Are like basically it contains some negative comment about somebody. So that kind of a speech, like that kind of a data set we have. In that data set, we will identify whether something is a hate speech or a normal comment or normal tweet. So these are the two assignments or experiments we have here in our last session. Actually, these are actually important and interesting as well for you because these are real world data sets. So it is actually important that you learn, to work on real world data sets. So this is 11 to 12. We'll start with 11 first. So which is sentiment of tweets. So yeah, let me delete, disconnect and delete. Yeah. Okay. So I think my screen is visible as well. So let's read the problem statement once again. Identify the sentiment of the tweets in the problem. In this problem, you are provided with tweet data to predict sentiment on electronic products of netizens. So I went through this problem statement, found some resources as well. So I provided the link as well here. If you click on the link, you will see some data set here, test.csv, train.csv. We have the data set available, code available. So I just downloaded the data and kept it in my drive to run it. So that's why I kept the link as well. So whenever you are, going to, obviously, I'll send all of these codes like 1 to 12 in a zip folder to you. Like Ramakrishna Garu will share this data with you. So you can actually use this link if you want to, get the data as well. So, but anyways, otherwise, I have the folder here. In this folder, we have data and we have codes. So all the code related, files will be in the codes folder. All the data related, that is CSV files, will be in this folder. So also, I would encourage you to also maintain this kind of a file structure. So even if you share it to anybody else, so they should be able to understand what is what. So that's why you maintain codes and data separately. Actually, we should start using GitHub as well. So in industry or in research or anywhere, nowadays people are using GitHub a lot. So that's a good practice. Let's see, like if we get a chance later, we'll see how to use the GitHub as well. So yeah, this is the link basically. So now let's go to the actual assignment. Sentiment analysis remains one of the key problems that has seen extensive applications of natural language processing. This time around, given the tweets from the customers about tech firms who manufacture and sell mobiles, computers, laptops, etc., the task is to identify if the tweets have negative sentiment towards such companies or products there is, yeah, something extra. Yeah. So the problem statement is you have some companies, manufacturers selling mobiles, computers, laptops. Users are giving some reviews, and based on the reviews, you want to identify whether some product is good or bad, right? So usually, even when you are buying something, you will go and check the reviews. But checking the reviews is a lot of a very hectic process. So that's why if you observe, maybe Flipkart, I guess, Flipkart. Let's see. So now we have these shoes. Let's see. Okay. Here we have 3.9 rating. I think in Amazon somewhere we get. Here are the reviews. Let's search for some TV. Yeah, we have reviews all over here, but I think in some website along with reviews, here we are having anyway rating and all, but along with it we see sound wise what is the review, what is the percentage, like how many people are happy, speakers, are they good, TV screen, different aspects of it are there. No, even for that we have the numbers. Okay, 3.8 or like for a 10 rating. Okay, sound wise 8 people are happy, picture wise 9 people are happy, something like that. So what they do is they actually read this, automatically process this using NLP, and then identify what is the rating for each feature of the TV as well. So that's what, like, there are so many real-time applications of this sentiment analysis. So yeah, identify the sentiments. Provided with the tweet data to predict sentiment on electronic products of netizens. So here, usually, like when you don't like it something, there is a chance that people will use profane or vulgar terms in the tweets. But most of the data is clean. The profane words are replaced with these hashtags, are basically special symbols. However, please note that the data still might contain the text may be considered profane, vulgar, or offensive. So this is the basic problem statement. Let's anyway. I told you already. The collab we will use collab in our all the experiments. So here we usually keep the data in the Google Drive somewhere in some folder. So this is the lab like folder that I'm maintaining for second year NLP, second year ML, third year ML. In second year ML, I have all the codes and data as well. So now I have this data, right? But how do I access this data, which is in the Google Drive, right? But my codes are here. So for that, what we do is we will use this two lines. What it will make us is, so whatever the drive we have, let's say in your laptop, you have C drive, D drive, all of those drives, right? So if I run this code, what it makes is your Google Drive will become like a C drive or a D drive to this code. So you can actually copy paste the link here somewhere whenever you want. You will be able to access your Google Drive through your Colab notebooks. But if you are running this code in your local disk, so you should remove this. You don't have to use this. Only in Colab you are supposed to use this. But in your laptop, if you are working on assignment for in the laptop, you actually don't need to run this file. I mean, like run this code. Okay, now what happens is here in the files icon, I'll be able to see my drive here. So in my Google Drive, like we have all the folders, Kite Labs. So you see all the files are available here. Now I can copy path from here and copy paste it whenever I want. So now let's, this is our import module. In this import, we'll use NumPy, Panda, Cbun for plotting. NLTK, you already know that, okay, if you are doing NLP Lab, then you should know we are going to use NLTK toolkit, like how to use it and everything you should learn. And this is one. The very first assignment where we removed hashtags, mentions from tweets. So that is used, like that is done using regular expressions, right? So the same module here, import RE. So and then for classification, we will use all of these features. We don't have to actually use everything. Linear SVC, sentiment analysis, random forest, Gaussian NB. We have these available, but we don't need to use everything. We can use only one or two. So this is about sklearn also, or scikit-learn. Even for this, we gave some introduction. So these are actually very important. I think this is a summary basically. So if you want to learn machine learning and if you want to learn NLP, you should learn NumPy, Pandas, plotting, Cbun, Matplotlib, NLTK, scikit-learn, regular expressions. All of these are important actually. So you should be, able to use all of this whenever you want. So you should know how to use this basically. So this is all about importing modules. Now let's read the data. So like I said, train data, test data, we have to read, but these are available here. So let me actually remove the path here and then copy paste whenever. So here on the left side, you can see, right? So here in NLP, I have data. So first I'll copy this path. And pasted it. For now, I have to paste, or I'll get path for test data. Copy path. Okay, now I have all these paths. Okay, first I have to run this file. So this, you see the error, name PD is not defined. So that PD is available now after running this import. So yeah, once I run this, now you will be able to see what is the data that we have here. So fingerprint, pregnancy test, finally transparent silicon case. We love this. Would you go? Memories. Wide I know George. What an amazing service. Apple won't even talk about something. So you can see these are all related to some electronic products. Now let's train this and then test. So now we can see in train, we have 7,920 tweets basically. In test, we have 1953. Combinedly, we have data frame df about 9,800, almost 10,000 data files we have, or data records, or tweets. Basically, we have 10,000 tweets. So this is the data we have. So now let's see how many are positive sentiment and how many are negative sentiment. So if it is 0, then it is a negative sentiment. If it is 1, then it is a positive sentiment. So one label equal to 1 is around 2000 something, that is 2026. But for 0, we have 5894. Now, okay, now what we did was we read the data, but we have to clean the data as well, right? First. So for cleaning the data, we have some code here. First, remove emails. If you remember, all of this we did in our first assignment, very first assignment, where we use regular expressions. So if there is no, like, it is very simple. Here, what they did was, first they split this into words. All your text will be split into words. If it is not there, if there is no at the rate, then we are keeping it. If there is an at the rate, then we are simply removing it. So that is one type of cleaning, basically. So you take your text and split it using spaces. Now what you have is all words, and if there are any emails and everything. So in that word, if there is at the rate, then he says that, okay, it is a email and I don't want it. So if there is no at the rate in I, then I will keep it. Otherwise, I will leave it. So this is about removing emails. Coming to removing addresses, also we have come, like we did this earlier. So HTTP column, and then non-space, non-space character. So if there is anything that is followed by HTTPS or HTTP, then we are treating that as URL or web address. Now we are going to remove all the lower cases. That is, if there is anything that is not within A to Z or A to Z, like small letters and capital letters, then also we will remove that. That is basically removing all the special symbols. But remember, we should not do this before these two, because these two are actually using these special symbols. So that's why first remove emails, then remove address, then remove the text. I mean, like, special symbols. And then if there are any Unicode characters, like, because this is a real world data, sometimes what we will get is something like this, or some Unicode characters which are not even English. Let's say if something is in Spanish, so even that we have to remove. So for that we will use Unicode characters, right? So those will be removed using Unicode characters. Convert to lowercase to maintain the consistency. So first we removed emails, then URLs, then special symbols, and if there are any Unicode characters, we will remove those as well. Now we have like, we'll convert everything into lowercase first, and then finally remove double spaces. If there are any double spaces, we will remove the double spaces. Like here, /s means space, ++ means more than one. So this is This is the function that cleans the text. So what we will do is df. We are actually cleaning it, right? We have data, our data in this df, the header. Now what we'll do is for each row, we will apply this clean text function. So for that, we will use lambda x. df.tweet.apply lambda x clean text will result in some cleaned data. Let's print this as well. You see, now we have two rows, actually, sorry, two columns. One is tweet and the other is clean tweet. So here you can see hash, pregnancy, and the URLs and everything is removed. So hash fingerprint became fingerprint, pregnancy became normal pregnancy. Everything is in lowercase now. There is no URL anymore here. You know, so that is what we did, right? So now again, what we are going to do is this is, das, I. So all of these are actually not required because they don't have any information. So that's why we have this list called stop words. In the stop words, we'll have all the words which are usually not really required. A, about, above, after, again. So all of this, all of these words are like useless basically. They don't give any information about sentiment of the tweet. So that's why we'll remove all of this. If there is any word A, let's say here we have A, right? Finally, A transparent. So this will remove this A. So yeah, so we have this stop words. From the stop words, we have to, we have these tweets. From the tweets, we have to remove the stop words. So for that, we have another function, apply lambda. So first what we will do is, first we'll take the x and then split it using spaces. Then we will have all the words. The words which are not in stop words. So if the word is not in any, like it is a list, right? If your current word is not in that list, then what we will do is we'll keep it. If that word is there in your list, then we'll remove it. Like if it is there, if it is not in it, then we'll keep it. If it is there in your list, and we'll skip it. And then finally, once we have it, we'll simply, because first we split, no? So now we have to join it using space. So df clean teeth equal to this one now. Let me run this as well. Now we have the clean tweets. Let's again print. See now, here we have A, but here we don't have any A. Finally, a transparent silicon that became finally transparent silicon. So there is no A anymore. We have VWE, V here, and that V also is removed. So what we have is now all the keywords, like we removed all the unnecessary stuff from the data. Adding new feature length of the tweet. So what we did was word count. We added one more column with the number of words in the data frame. Sorry, number of words in the tweet. So in this tweet, in this clean tweet, we have 12 words. In this second one, we have 11 words. So we added it, like it is not exactly required, but it will give us some idea, like what is the average length. We can see most of the tweets having about 10 keywords, like around all the values are around 10, at least whatever we can see here. So now let me download some data. Okay. This Vader lexicon, it will have all the tweets, I mean words and their corresponding sentiments. So that's why we have this Vader lexicon. So for sentiment analysis, we have a function called sentiment intensity analyzer. We call it SID. SID dot polarity scores of some first row will calculate it. So what we can see here is from scores, like from the cleaned data, negative sentiment, neutral sentiment, positive sentiment, that we'll calculate. And then finally compounding will whether to like the compound score will be kept here. So using this sentiment intensity analyzer, we can actually calculate what is the sentiment for each. So finally, what we are left with is this, and we are removing all of the tweets and everything. We are just keeping clean data basically, and this is the label, final label. Which we already have. So now what we'll do is, first we have to remove if there is any null values, we'll remove it. If it is a null value, then we call it test data. If it is not null, like if the label is not null, then it becomes a train data. So train data, like first what we did was we combined everything, right? So that's why to now for cleaning purpose, we combined it. After all the cleaning is done, we'll separate the test data and the train data again. So that's what we did here. Why? Like you can see label is available for these starting tweets, but in that ending tweets, there is no label, right? Only for test data, we don't have label, right? So that's why if there is label, then we call it train data. If there is no label, we call it test data. So finally, we got our test data and train data back. Now let's define what is X and what is Y. Our X is our tweets, our Y is our label corresponding to the tweets, and our test set is this. There is no label here. So X is X, clean it data, and we are converting that into, we are splitting the test data itself into two parts. One here you can see 0.3, right? Here 0.3 means 30%. So test size will be 30%. Rest of it will be, the 70% will be your train data. So now you have your clean data, and you removed all the test data aside. You kept the test data aside, and from the train data itself, you created X train, X test, Y train, Y test. So now you have the data. First, what you have to do is you have to convert your text into numbers now. So for that, if you remember, we did the TF-ID of bag of words earlier. So we will do the same thing now. So here we are importing a TF-ID of transformer, and vectorizer we have count vectorizer, and then first we are fitting the data, and then train data, test data, dimensions we will get. So once we have the data, like once we convert the data into numbers, what we have to do, we have to choose the classifier. So here in this example, we are going to use random forest classifier. So here estimators, like if you have done this ML lab, maybe there you might have like using a random forest classifier. So in that random forest classifier is like nothing but it will take 200, 300 samples from the data, and it will create trees. So that's why we have 200 here, and then finally we'll fit the data, our training data, to the model, and then random forest will predict, and our accuracy will be shown here. So on our test data, we have about 86% accuracy. Let me run this as well. Now we want to plot the confusion matrix. Import iter tools from sklearn metrics. We are using confusion matrix, and we wrote some function for confusion matrix to display. Like calculating the confusion matrix is easy, but displaying is little bit hard. That's why we have all of this code. So if you plot it, you can see like most of our accuracy is good only. So not negative, we are able to predict that as not negative almost 95 times. If it is a negative sentiment, and you should be able to say negative, so that we are not able to do it well, because here we have about 95% accuracy, but here we have we have only 60% accuracy. So what is happening is, so the actual tweet is negative, but what you are saying is not negative. So that's a problem. But yeah, like the better your model and better your representation is, the accuracy will improve, but it is still a decent accuracy. That 86% is still a decent accuracy. So this is what our first case study is. So Let's move to the second case study. So this actually I'm planning to do it in front of you because the assignment is actually designed based on some article in Analytics Vidya. So here we have this blog. Based on this blog, the problem is designed. So that's why I thought, why not, go make you go through this blog and run the code in parallel. So let's actually go through the code. It's here itself, like blog itself. So comprehensive hands-on guide to Twitter sentiment analysis with dataset and code. So introduction. In natural language processing, hotbed of research and data science these days, one of the most common applications of NLP is sentiment analysis. From the opinion polls to creating entire marketing strategies, this domain has completely reshaped the way business works. So all of this is not needed. Yeah, let's directly jump into the problem. So in this article, we'll learn how to solve sentiment for hate speech basically. We'll do so by following a sequence of steps needed to solve a general sentiment analysis problem. We'll start with the pre-processing and cleaning of the raw text of the tweets. So whatever we have to do, usually it is mostly about cleaning. Once we do the cleaning, then we'll convert that into vectors. Once we have the vectors, then we'll model it. After modeling, we'll do evaluation. So then we'll explore the clean text and try to get some intuition about the context of the tweets. After that, we'll extract numerical features from the data and finally use these features to train the models and identify the sentiments of the tweets. So this is the overall idea. So this is the table, like table of contents. What we are going to do is first understand the problem statements, then clean the data, then understand, basically do the EDA, exploratory data analysis. So visualizations and all of that, we'll do it on as a third step. Fourth step, we'll do extract features from the cleaned data. That is nothing but converting your text into numbers. After that, we'll do model building for sentiment analysis. So understand the problem statement. So the objective of this task is to detect hate speech in tweets. For the sake of simplicity, we say a tweet contains hate speech if it has racist or sexist sentiment associated with it. The task is to classify racist or sexist tweets from the other tweets. Formally, given a training sample of tweets and labels where label equal to 1 denotes the tweet as racist or sexist, and the label is 0 denotes tweet is not racist and sexist. Your objective is to predict the labels given on the dataset. So basically, if your label is 1, then it is some negative comment. If it is not, then it is okay. It's a normal comment. So our evaluation metric is F1 score. So what he wrote is, personally, he likes this task because hate speech, trolling, and social media bullying have become very serious issues these days. And a system that is able to detect such texts would surely be of great use in making the internet and social media a better and bully-free place. So basically, he's saying that it is very important problem. Why? Because it has a lot of applications in, like, in real time. In social media, we can see a lot of quarrels. In from there, you will see one community is abusing some other community. For example, in US, people like white folks usually, like not usually, but some of the white folks are actually racist. So they make comments about black people. And similarly, some regarding women, there'll be some negative comments in the comments or tweets. And some German people, which are who are called as Nazis, they are against Jews. So this kind of biases and everything, it exists in real life. So that is usually visible in front of us in social media. in the form of tweets or in the form of comments. So it will be very helpful if you are able to identify it, automatically. So that's the basic problem statement. So the second part is pre-processing and cleaning. Take a look. So basically, you already know what's cleaning means, right? Basically, even we did this in multiple assignments. Even in our 11th assignment, we did this cleaning. So yeah, first I think have I yeah, let me, like, what I will do is I'll explain here, but what are the code that is here, I'll paste it here and then run it in front of you. So first, like, this code won't be, this Google Drive related code won't be available here because he may be using something else. But yeah, this is required for us. And now we have importing module. So like regularly we use pandas, regular expressions, MATLAB, string, NLTK. So all of this we are using. And let me separate this into new cell. So I just read this train data and test data. Where did I read it from? I have a drive. In that I will copy paste the paths and then I can run it now. So this is the train data. So when a father is dysfunctional and all of that, so lift credit can't use, birthday, your majesty, I love you to take with all the time and all, facts guide. So we have some data, like I'll show you from here itself. So this data might contain some abusive words because the data, the problem that we are working involves in this. So here you can see white establishment can't have black folks running around loving themselves and promoting our greatness. So I'm not interested in linguistics that doesn't address this. Racism about power. Marked Obama for being black. So if you see, whenever there is one, there is some racist comment or something. So this is the kind of data you have. If it is 0, you can see this is us all of this year waiting for the show to start our third year running. So something like that. So you don't actually have any. If it is 0, then it is just random tweet. It doesn't have any negative words in it. So that is the kind of data we have here. Then first what we will do is where is it? The data contains 3 columns: ID, label, tweet.label. Our tweet.label is a binary target variable, and tweet contains the tweets that will clean the process. Initial data cleaning requirements that we can think of after looking at top 5 records. So the Twitter handles are already masked as @user due to privacy concerns. So these Twitter handles are hardly giving any information about the nature of the tweet. So we can remove this @users. We can also think of getting rid of punctuations, numbers, and even special characters, since they don't help in differentiating different kinds of tweets. most of the smaller words do not add much value. For example, PDX, his, all. So we will try to remove them as well from our data. So if the your text is very small, like 3 characters, then we will remove it. Like even less than 3 characters, we will remove it. Once we have executed the above 3 steps, we can split every tweet into individual words or tokens, which is an essential step in any NLP task. In 4th tweet, there is a word love. We might also have terms like loves, love, lovable. So in the rest of the data, these terms are often used in the same context. If we can reduce them to their root word, which is love, then we can reduce the total number of unique words in our data without losing a significant amount of information. So what we want to do, we either want to do stemming or lemmatization. If you remember, that was our second assignment. So that's why I'm saying this is really important, the 11th and 12th, because whatever you learned in the previous 10, all of that are being used in 11th and 12th. So for the removing Twitter handles @user, we have first we'll combine this data, and then yeah. Oh, I already copied it here. So first I'll create the combination, like test and train data. I'll combine it and then do the processing, and then I'll separate it again. Now let's yeah. So the pattern is this @ followed by some symbols like word characters. So that we will remove. That is one. Next, removing punctuations and numbers and special characters. For that, we have another code. I copy pasted here. Combi, this tidy tweet combination. Here the pattern is this. So replace anything other than A to Z in small case and capital letters. Anything other than that, replace it with empty string. Remove short words. We have to be little careful in here while selecting the length of the words which we want to remove. So I decided to remove all the words having length 3 or less. For example, terms like HMM, that is means you usually wrote like O, are very little used. So it is better to get rid of them. So words which are having length less than 3, we'll remove that. So let us take another look into the, now let's see like how the new data looks. So this is the old data and this is your new data. So this users, hashtags are removed. Not exactly hashtags, but special symbols. If they're alone, then we are removing it. But we want to keep the hashtags because they are useful when you are like in feeds. Definitely hashtags are useful. So that's why we are keeping the hashtags. After that, we will do the tokenization. Now we will tokenize all the clean tweets in our data set. Tokens are individual terms or words, and tokenization is the process of splitting a string into. So basically, this is a sentence, right? You want to convert this sentence into list of words, basically. So your data, when, father, dysfunctional, selfish, all of this is becoming into a list with different words. Once you have these words like separated, like tokens, now you want to do the stemming. Stemming is a rule-based process of stripping the suffixes like ing, ly, es, yes, etc. from a word. For example, play, player, played, plays, and playing, all are different variations of the word play. So from NLTK, we have stemmer, Porter stemmer. Using the Porter stemmer, we'll do the stemming. Actually, you can actually use lemmatization as well, but that is little, time taking process. So that's why we are doing the stemming only here. Now let's stitch these tokens back together. So first we converted the sentences into tokens, then we stemmed these tokens when father dysfunctional became defunct. So dragging became drag, I guess. Drags became drag. So, and now we want to combine everything back into single sentence also, I think. Let's actually now you can see the data, clean it data again. So finally you have tidy tweet here. Now we will do the story generation and the visualization from the tweets. In this section, we will explore the clean tweets data text, exploring the and visualizing data. No matter whether it's a text or any other data, it is essential step in gaining insights. Do not limit yourself to only these methods told in the tutorial. Feel free to explore. Before we begin exploration, we must think of and ask the questions related to data. What are the most common words in the entire data set? What are the most common words in the data set for negative and positive tweets respectively? How many hashtags are there in a tweet? Which trends are associated with my data set? Which trends are associated with either of these sentiments? Are they compatible with the sentiments or not? So these are the questions that you will try to ask whenever you are given some data. So you want to find patterns. Hashtags are there. So which hashtags are related to negative data set, which hashtags are related to positive data set and all. So understanding the common words used in the tweets, we'll do it using word cloud. So for that we have this code. So word cloud is a library. So in that it will fit all the words that are usually used. Most of the frequent words will have higher, bigger size. See, actually it is supposed to be this, I guess. So this became this. The bigger the the font size, that many times it has come in our data set. You can see life, birthday became by a day, make, thank you, happy. Yeah, these are the most used words. Here you can see Trump, tonight, stop. Some bad words are also here. So yeah, this is word cloud. So in non-hate speech, like in normal comments, what are the maximum, like what are the words that are there in normal comments? So that is what this is here, only containing positive words. You can in racist comments, what are the maximum words that we see? So here also we'll provide one. So here you can see Trump, Obama, woman, video, stop, girl, listen, retweet. So some bad words, fight, liptard, racist. So Allah soil. So all these you can see, some of them are actually related to some bad words or some racist words. Now you have to understand hashtags in Twitter are synonymous with ongoing trends. You try to identify particular point in time. We should try to check whether these hashtags add any value to our sentiment analysis task or not. They help in distinguishing tweets into the different sentiments. Now we will see like what are the kind of hashtags we have in our positive sentiments. So love, positive, smile, healthy, thank, fun, life, FM. So all of this are in positive positive data. In racist data, we'll see what are all the most common words. Trump, political, Allah soil, liberals, libertad, so SJW something, retweet, something like that. So you can see that most of the related negative or racist related comments are about actually coming from politics or something. So because of that, we have Trump, politics and all. So now we have data. Now we want to first convert this into vectors. For the vector conversion, we will do TF-IDF vector conversion. TF-IDF here. And then finally, we will use our logistic regression here. So what we are doing, we have the data, we cleaned it, we analyzed it, then converted it to numbers using TF-IDF or count vectorizer. And then finally, we are using our classifier. So we have about 53 as our F1 score for similarly, we'll try for TF-IDF, what will be the score? So here we have 54. You can see with the bag of words, we are getting only 53%, but in our TF-IDF, we are getting 54% F1 score. So this comes to the end of our lecture. So what we covered was in 11th assignment, we did the sentiment analysis. In 12th, we did the hate speech detection related task. In hate speech related task, first we have the data, we cleaned it. After cleaning, we represented it using like first we did the data analysis like this, just to understand how the data looks for our humans. And then we converted that into numbers which can be understood by machines. Once the numbers are there, you can always train the model, or basically you can actually convert it into vectors. Then after the vectors are there, you can train a model like a classifier, and then finally see what will be the score, FN score or anything, or even for that matter, accuracy is also okay. We'll find the accuracy on our test data. So what we observed is, with the bag of words, we have 53%, but with TF idea, we have about 54. So that is actually a good number when it comes to FN score. So this FN score can be, maybe it will be usually be around 80% accuracy. So FN score is different from accuracy here. So yeah, from like with this, we will end our session. Let me stop the sharing. So yeah, I hope you learned something from this session. All the data that I have, I'll convert that into one link. I'll paste it. Let me do it right now. Share. Copy link. So in messages, where is message? Where can I chat? Chat. Let me check if it is, if the share option, everyone that has anyone with the link. Yeah. Done. Yeah, I shared the link, but yeah, I didn't mean I can sharing owner viewer. Actually, I can't make you okay a editor, because so many people will start using it. So even if they remove it by default, it becomes a problem. So everyone can actually use this link and make a copy to your Google Drive and then start using it. So okay. So thank you everyone for your patience and all. Yeah, thank you. I mean, with this we'll end our session.